Okay, page 2, lesson 1. Students will be able to solve equations with radicals and check for extraneous solutions. Extraneous solutions. That means we're going to work the problem, find out what x equals. If we get, let's say, x equals 2, we're going to put the 2 back into the equation and make sure that it does work in the original equation. If it doesn't work, it's considered an extraneous solution. This means it's not helpful. We're not going to put it down as an answer. And if it was the only one we had, we're going to say it's either does not exist or there's no solution. Typically in these problems, you're going to get 1 or 2 answers. So if there's 2 answers, you have to check both of them. And chances are that one won't work and the other one might. So you need to check for extraneous solutions when you're using problems with radicals in it, okay? So solve equations with radicals to check for extraneous. It says if there is a radical in the equation, the root must be cleared. To clear the radical in an equation, follow these steps here. Okay, step 1, properly move and combine terms so that the radical is alone on one side of the equation. All right, so look at example A here. The radical is alone on one side of the equation. That's already done for you in the first one, so we can practice, okay? Step 2, raise each side of the equation by the power that is the same as the index of the radical. All right, so look at number 1. The index isn't there. It's assumed to be a 2. There's an index of 3. There's an index of 4. So I'm going to raise each side of the equation by the power. This will clear the root when simplifying. Okay, so if this is a square root, we're going to raise it to the square to 2 power of 2. And when you do that, you're left with a radicand by itself. All right, and once you're there, you can solve as you would any linear equation. Get the x by itself on one side, move the constant terms together on the opposite side, and isolate your variable. X equals 2. And then I am supposed to check for extraneous solutions. When the index is even, the solutions to the equations must be checked back in the original radical and equation. If the value does not work, the value is not considered a solution to the equation. In other words, it's extraneous. Extraneous solutions are never given as part of your answer. So don't put it in your homework online, okay? Just leave it off. If there isn't anything, then there is no solution, and see if they want you to use does not exist, okay? So I just did this one. I got a 2. I need to put it back in the original equation. 7 times 2 equals 4. That is 14 plus 2 is 16. Square root of 16 is 4. Yes, that's right. Yes, that is a solution. Okay, let me get some room here. All right, this one, number 2, is a cubed root, so that means I need to cube or raise it to the power of 3 both sides. So that leaves your radicand alone, and negative 4 times negative 4 times negative 4 is negative 64. You add 1, moving that over, you get a negative 63, which is kind of an odd thing. It says when the index is even, I should check, but I'm feeling a little insecure about that answer. Let me put that back in. This is going to be a negative 63 minus 1 is a cubed root of negative 64, which is negative 4. So that is a correct answer. Right there. Sorry, I'm writing it down somewhere else. All right, so the next one has a 4th root, so we want to raise it to the power of 4. So this is going to be 3x plus 6 equals, what is negative 3 times negative 3 times negative 3? That's going to be positive 81. Use your calculator for that if you need to. Solve. Divide to isolate, you get an x equals 25. This was an even root, so it must be checked. 4 fourth root of 3 times 25 plus 6 equals negative 3. So that's 75 plus 6 is 81. The fourth root of 81 equals negative 3, and that's not true. Positive 3 is not the same as a negative 3. So that solution isn't any good. So your response is no solution, or check your homework. Maybe they need a solution doesn't exist answer. Okay. All right, so let's go back up here. Step 1, properly move and combine terms so the radical is alone on one side. So if you get an equation that looks like the next one here, the radical is not alone on one side. So we need to move it, okay? Properly move it to the other side. Since it's a negative 3, I'm going to add a positive 3, which makes it go away on this side. And 2x plus 3 radical equals 3. And then that ends up where the first one started. I just want to double check up here. What was this other one I haven't read yet? When a non-radical side of the equation ends up squared with a variable alone. Okay, so that's next one down. That's more complicated. So right now I'm just getting my radical alone on one side. Then I am raising it to the power of the index, which is going to leave the radicand alone, and we need to solve. X equals 3, and since it was an even radical, we want to check that 3 by putting it back in the original. Let's go all the way back to the original, because what if I messed up this first step? So I prefer to put it all the way back there. So this is going to be 6 plus 3 is 9, minus 3, so 3 minus 3 equals 0. That's correct. So that is the solution, okay? This one, we're moving the x to the other side. It's not a constant term, but we still need the radical alone on one side. Okay, and then it's an index of 2, so we're raising both sides to the power of 2 to clear that away. All right, then notice we're left with an x squared somewhere. So let's go back to the step 3 thing. It says when the non-radical side of the equation ends up with a squared variable alone, that's what I've got, properly move all the terms to one side, keeping the squared variable positive equaling 0. All right, so step 1, I got the radical alone on one side. Step 3 said, step 2, sorry, let me start over again. Step 1, get the radical alone on one side. Step 2, raise to the power of the index. When simplifying step 3, if the radical on one side ends up, it's a variable squared, I need to move these other terms over. So I'm going to get 0 equals x squared minus 6x plus 5. Then it says to make sure it equals 0, and then factor and solve using the zero product rule. All right, so that means it needs to be factored. So I believe that's going to factor x, minus 1, x minus 5 equals 0. I am going to run out of room here. Let's see. So x minus 1 equals 0. That's the zero product rule. Do you remember that? It says that you set each factor to equal to 0 because one of them has to be equal to 0. So if you solve for both of these, add 1 to both sides, you're going to get x equals a positive 1 and a positive 5. And our index was positive, so I have to check both of them. Sorry, this is getting a little messy here. Let's do it in another color. So let's try the 1. 6 times 1 minus 5 minus 1, right, got to put that in for the x, is going to be 6 times 1 is 6 minus 5 is 1, so 1 minus 1 equals 0, so the 1's okay. And then 6 times 5 minus 5, so that's 30 minus 5 is 25, is 5 minus 5 is 0. So that's okay. So these are both correct. Don't have any extraneous values for this one. All right, so look at all that's going on here. My radical is certainly not alone on one side. So the first thing I need to do is move the 8 out of the way. Okay, that's 27. Then I need to get rid of this 9. The radical is truly not alone yet. Okay, and then we need to square both sides. Oops, put this radical back. Square both sides. So this is going to be x minus 3 equals 9. And we're going to move 3 over. We're going to get x equals 12, and we're going to check. So back in the original problem, 8 plus 9 times 12 minus 3 equals 35. So this is orders of operations, says in here, this is 3, this is 9. So 8 plus 9 times 3, right? The number shoved against another number is a multiplication. 8 plus 27 equals 35, which is true. So, yep, that's the right answer for that one. Okay. All right, at the bottom here, it says, after isolating the radical on the other side's a binomial. Okay. So I didn't finish reading those instructions, but I know that the radical is alone on one side already. So what I'm supposed to do is raise to the power that the index is. So that's going to clear this out on this side. But that last little bit up here, it says, when there's a binomial left on the non-radical side, square properly so you can FOIL or distribute, then move all to that side and factor and solve. That sounds very involved. Let's go back over here. So that means, notice up here, when you just squared the x, you just got that. Well, now, you cannot distribute this too. That's what it means by distribute it properly. That's what it means. I have 2x to the 3's, which means that needs to be factored, or FOILed, and distributed. All right, and then it said move all factors to one side because you're going to have to, all terms to one side because you're going to have to factor. So add their opposites. So coincidentally, the middle term dropped away, but that's okay. I'm going to get a perfect square minus a perfect square, so those factors, the root plus or minus the root. All right, and then I need to set them equal to 0. So this one is going to give me a positive 2, and this one's going to give me a negative 2. So x equals 2 and negative 2, and it was an even root, and they both have to be checked in the original problem. So 2 plus 3 equals the square root of 6 times 2 plus 13. All right, so that's 5 equals square root of 12 plus 13 is 25. Oh, good. So that's 5 equals 5. So the 2 is okay. How about the negative 2? Negative 2 minus 2 equals oops, minus 3. Hang on. Original problem. Negative 2 plus 3 equals the square root of 6 times negative 2 plus 13. So this is going to be 1 equals the square root of negative 12 plus 13 is 1. 1 does equal the square root of 1. So that's good. So both of them are correct for that one. So I didn't have any extraneous solutions for that one. All right, let's try this one. Radical is not alone on one side. Move the constant term away. So then the radical is alone on one side. And these are not like terms. Do not add them together. That's a binomial now. So that means you need to square that. So this is going to be the radicand alone, but this side's going to be x minus 5 times x minus 5. I recommend you writing that twice so you don't mess up the FOIL, okay? X squared minus 5x is minus 10x, and then negative 5 times negative 5 is a positive 25. And these terms over here need to be moved over. All right, so I'm going to get 0 equals x squared minus 14x plus 24. I believe that's going to factor. Twelve and 2 make... So 12 and 2 are factors of 24 that add up to a negative 14. Signs are double negative because the negative is first and then the positive. So that means x equals a positive 12 and a positive 2. Both of them have to be checked. All right, so... 12. Okay, so 5 plus, that is going to be 48 plus 1 is 49. Square root of 49 is 7, which is 12. That one's good. All right, the other one was 5 plus square root of 4 times 2 plus 1 equals 2. It's really important when you're checking to put those numbers back in correctly. You don't want to mess up the check thinking you have an extraneous solution when you don't. Okay, so make sure you're putting those back in correctly. 5 plus 8 plus 1 is 9, is square root of 9 is 3. And that doesn't work. That doesn't equal that. So that's not the right answer. So all we have is x equals 12 for that one. Okay?